Good afternoon, students. How are you?
Good afternoon, sir. We're okay.
Good afternoon, sir.
Matthew, why question you for Matthew? What is the problem, Matthew? Where you have to go, Matthew? Come, talk to me, Matthew. Where you have to go?
Class this, sir. Relaxation.
Like what?
Remember, no, sir. So,
Also, because today's the last class and I want a relaxation?
yes, sir.
Watch here. All right, do me a favor. The relaxation that I give you now, I sent you quite a bit of questions on creamers. I sat down and did, and you can, by the way, can you agree with me with that on that?
So what do you mean, sir?
I sent you, well, I'm thinking that I sent you the Kramer's handout with the questions and solutions. Did I send it off to you?
Yes,
In the
sir.
WhatsApp group? Yeah, man. So I sat up and did quite a bit of questions there for you. So what I'm going to ask you to do is to use about 20 minutes thereabout, because I'm finished with Kramer's, you know. So tonight is going to be a very relaxed class, yeah, because I'm going to start and finish fact and remainder theorem, which is really not difficult. There are only 3 areas on the syllabus, and I can condense those 3 areas so it is that we can finish off. So let me just give you a little time to put your feet up and just go through the questions. You don't have to, I did the solutions for you already. So just go through the questions and I'll give you about 20 minutes and then we'll come back. And yes, if you do what I ask you to do, we can finish off early tonight. Or we can have a little Zoom party. All right? Later. Soon come.
Sir. Anybody can repeat what sir said, please?
Go through the questions and solutions we sent through WhatsApp.
Tantan, what you say?
There's so many.
What does that tell you? You said that I sent you so many questions?
In the document, right? That you want us to go through,
In the
right?
document. Yeah, man, in the document, yeah. I did all of that.
Question though?
Huh?
Any question in the document, because there's a lot.
Okay, so you see how your teacher look after Uno? I sent you, I sat down and did all of those questions and typed the solutions for you. So anybody who's supposed to be tired is me. So what I want, there are 3 of them that I didn't do the workout for, but the answers are there. Fatigue took over. But just, yeah, look at any few of them, any 3 or 4 of them. You don't have to all look at the same ones. Look at any 3 or 4 of them and just go through so that you can concretize what is happening. I know the ones who are understanding this topic, know them very well. So I'm going to encourage us to just go through, just to put the icing on the cake, and then in another 20 minutes to half an hour thereabout, I will just start and finish maybe in about an hour and a half or 2 hours at most. The fact and remainder theorem. It's really not difficult. It's just procedural, and then we just call it a day. And for this leg of the semester. All right, so start working.
Okay, sir.
No problem. All right. Oopsie daisy. Okay, so that's more than enough time for you. Okay, that's more than enough time for us to move on. I'm seeing some people leaving the session, but that is fine because I'm going to be introducing something here. And whatever I'm introducing here, I won't go through necessarily the full gamut of it, recognizing that you guys are a little fatigued, but I have to be true to my calling, and I can't give you the time free of cost. So we have to do a little bit of stuff together. So let me just ask you though, how are you with the Kramers? Are there any questions, any concerns? Let me know so that I can possibly deal with those. Are we okay with it?
I'm good, sir. I don't have any concerns.
Thank you very much, DT. Anybody else? Is that an overwhelming I'm good, or is there something that somebody has any
Sir, good. Just need to not do it so fast. Not do the work so fast and just check to see what sign needs to be changed and make sure you have the right values, right number, put in the right signs and stuff like that.
Right.
Yes, sir. And put in some practice.
Okay. All right. So my two T's are out saying the same thing. And if I were to confess something to you, this was one of the topics that I caught on to pretty quickly when I was going to school. But Tanil, trust me, it's because me know it and I like it, man. Me to work something, and not sometimes pay attention to the negative cofactor and the negative element and put a negative sign instead of a positive sign. And, when my answer gone all over the place, I just get frustrated and I have to check over everything again and I keep checking. And yeah, so what I do, and to this very day I do it, when I get the question and I write my augmented matrix, what I do is to look back at the question to make sure I copy the matrix correctly. Once that is done, I make sure I put in my array of signs. And then when I write my 2x2, my series of 2x2 matrix, every line I write, I just double check it because I recognize that it's a question that carries quite a bit of marks. And I don't want to lose any of those marks. So it comes with practice. It comes with practice. And also what is important is that you must make sure that those that have you have to put placeholders there. Just make sure so you have the placeholders, or else you're going to be in serious problems. But outside, to be honest with you, is one of the nicer topics that we would have covered. I mean, there are other topics that were pretty good, the indices and the logs weren't bad. But this is one of the nice ones that we need to put up and not forget. One of the things that comes to mind is I have to be deliberate now that all being well come January, that we need to spend, I don't know how we're going to do it, but I have to go use a portion of the Christmas break to figure out something. What I may have to do is to say, I'm going to use maybe an hour or a half an hour out of my class or whatever it is, or maybe the last hour or whatever it is, to ensure that we can do a little one question, or at the start of each session, I may just give a one question on one of those areas that we have already covered so that it will help you not to forget the things that we have done, right? What's the point I'm making? I've given you these handouts, these notes, and what I want you to do is to make sure that you go and do the questions repeatedly, not because you have previously done the question
oh, I did a question and I got it right and I understand it. No, that's not the aim. That's not the aim of us getting distinctions in integrated math this year. The aim is to practice and re-practice the question. So every time you get the question, you just look up the handout and say, okay, indices and logarithms is going to be a one question. And you do a one question here, you do a one question there, and you keep the information flowing, you're good to go. And I will do the same thing. Hold me accountable. I will do the same thing. I'm going to start writing some questions. I'll look at one or two questions here and there, and we can just drop it, maybe even the WhatsApp group, just drop a little one question here and say, your plan, run that, do that. And, we just keep things flowing because come next year, all being well, January, we have to go run, because we have 2 other modules to look at, plus a school-based assessment to look at, but I'm not frightening you. You guys have done pretty well so far, and I'm expecting big things. All right. So finally, are there any questions regarding my Kramers? It's now 6:28. We would have about 2 hours left. Really and truly, I hear from you. Last night I was in a class and I felt a little disappointed because the students are very tired, and pretty much I think I wasted about, of my 3-hour class, I think I wasted about 2 hours out of the 3 hours. So I'm willing to give you an hour off tonight. I'm gonna finish at 7:30, but it's on condition. It's on condition that we honestly, and this is going to hurt you, not me, you honestly understand the Kramers, and we can use an hour to just go through this other topic that I want to just introduce you with. Are we okay with Kramers? This is my final time asking.
Yes, sir.
Yes, sir.
All right, thank you. All right, so let's just move on to our fact and remainder theorem. It's not bad. You see, once you know algebra, that one is nice. And I mean, I'm not saying to you because I want you to understand it. I'm saying it to you because remember, all of what you are doing here, I once did it. And I'm going to use an hour to go through this. Really and truly, after me going through this, what is left is just for you to practice, honestly. So let me just do the introduction and see how far I can go, and we'll take it from there. So the last time I was using my tablet, I was challenged in sweet Jesus. All right, hold on. All right. All right, I'm just closing out some of these tabs. These tabs are, and I'm just recognizing how many tabs I have open. Maybe that's why the thing is so, honestly. All right, so I've closed them out. And I'm now going to be sharing my screen so I have more space to share. And then I'm sharing that. All right. So are you seeing the screen?
Yes, sir.
Are
Yes,
you?
sir.
Yeah, no, maybe so. Okay, good. So when we're in liquor school, Matthew, wake up.
Same there, man.
Good. When we're in little school, guys, and teacher says to us, 5 divided by 9. Me still love the mathematics and teacher couldn't run with them question, man. Well, teacher put them on the board, my box them up. Teacher couldn't play with me. The teacher said, Shand, 5 divided by 9. 5 into 9 goes one time, and 1 times 5 is 5. Why do we say 1 times 5 is 5 and put the 5 on there? Tell me. Because
Sir, I don't know. I didn't like this topic.
Subtracting the 5 from the 9 to get the remainder.
Excellent. Who said that?
Me, sir.
Nice. So, what it is that we're trying to find is the remainder. Yeah, man, very nice. It's the remainder we're trying to find, but yes, it's not good. The remainder we're fine. Because, I mean, I guess when I go a bit more in bigger school, bigger the little school, when I reach like grade 6. Are you hearing me now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, sorry. My internet just went out. I never knew, but yes, you're right. What we are finding is the remainder. What it is that we're finding. All right, there you go. So what it is that we're finding is the remainder. So 5 into 9 goes 1, and then 1 times 5 is 5. So in order for us to find the remainder, we have to subtract. In order for us to find that remainder, we must subtract. We have to subtract in order to find that remainder. Trust me. And that's what it is that I'm doing here, subtracting. So look at it. 9 is going to be equivalent to 1 times 5 plus 4. 9 is going to be equivalent to 1 times 5 plus 4. And that's how it is that we're going to be getting our 9. All right? So the 1 is known as a quotient. The 1 is known as a quotient. The 5 will be known as my divisor. The 5 will be known as my divisor. And the 9 is going to be known as the dividend. The 9 is going to be known as the dividend and of my remainder. So note the polynomial, which is what is under or will be under the square root sign, not square root sign, the division sign is going to be equal to the divisor times the quotient plus the remainder. It's going to be the divisor times the quotient plus the remainder. All right? Now, let us look at another example. 2 into 10. 2 into 10 goes 5 times, and 5 times 2 is 10. We have
The Wi-Fi bad, sir.
right here. Let me just show you what I'm about. I have the negative 10 right there. Right? We have the negative 10 right here. And 10 there.
Sir, your Wi-Fi now make it be great.
Yeah, because you're breaking up, sir.
Yeah, it's green, it's breaking up. All right, let us try this now again. Are you hearing me better now? Are you hearing me better now?
Yes, sir.
Yes, sir.
Yes, sir.
I apologize. Aye, aye, aye. All right, let us try this one more time. And Matthew calls it, Matthew said, I have no class tonight, so him just jinx my Wi-Fi, Hey, Matthew La Forest. Sure. All right, let us see what will happen. Let us see what will happen this time around. All right, hold on, please. All right, so let's go again now. So I was saying to you that the 2 into 10 goes 5 times. And then 5 times 2 is 10. 5 times 2 is 10. What is left under there? I don't know where that L comes from, but what is left?
0.
0.
0.
Excellent. 0 is left. 0, 0, 0, 0, 0 is left. I'm happy that nobody said nothing, because 0 is something. It's a big thing. You go on social media. It's a big thing. It's a big thing. 0 is a big thing. All right. Now, what this says, it indicates that 2, the divisor, is a factor of the polynomial. So 2 is a factor of 10. 2 is a factor of 10. That means 2 goes into 10 exactly. 2 goes into 10 exactly. It means 2 goes into 10 exactly. All right. Now, so the remainder is indeed 0. Now, let us look at another example, except this time it's going to be a variable. Here what the question says. Use synthetic division. Blow, so them big word there. Yeah, man, synthetic division. And in this case, it's going to be really long division. We just want some bright, so it's really long division to find the remainder when the polynomial 2x cubed plus 3x squared plus 7x plus 12 is divided by x plus 2. You see that ugly looking division? It is not bad. Don't worry about how it looks. I guarantee you by the end of today's class, you'll be getting it. I promise you. Now I want you to work with me. My x plus 2 is my divisor. My x plus 2 is my divisor. That is what I'm dividing the polynomial by. So it is called a divisor. That's what I divide a polynomial by. The polynomial is that term that has many terms. Poly means many. And I have many terms. So the 2x cubed plus 3x squared plus 7x plus 12 is known as my polynomial. And that polynomial has 4 terms. Each term is separated by a positive sign. So 2x cubed is one term. 3x squared is another term. 7x is one more term. And positive 12 is another term. And of course, my x plus 2 is my divisor. Watch me. Don't blink. Look at the screen. X, that x into 2x cubed goes 2x squared times. That x into this 2x cubed goes 2x squared times. Then I'm going to say, look at the spotlight. Then I'm going to say 2x squared times that x gives me that 2x cubed. And that same 2x squared times a positive 2 gives me positive 4x squared. Let's go again. X into 2x cubed goes 2x squared time. 2x squared times this x gives me 2x cubed. But because my divisor has 2 terms, I have to go back and multiply that 2x squared by that 2 to give me 4x squared. Now that I've used my 2x squares to multiply by my x plus 2, I need to find the remainder so that I can go through the division again. So that's why I draw that line, and oops, there's supposed to be a negative sign in front of that. So why I put it in parentheses, I am subtracting. You know this. That's the only way I'm going to find the remainder when I subtract. That's the only way I'm going to find the remainder when I subtract. So I'm subtracting. So that a negative sign should be outside there. Forgive me, I will get it there. I think I have it in the other questions, but I'm in the document. So I am subtracting. 2x cubed, that 2x cubed minus 2x cubed equals 0. So you notice you don't have any x cubed term down there, so because you have eliminated it. It's now 0. Watch me now. 3x squared minus 4x squared is a minus x squared. You're subtracting. You're trying to find the remainder. You're trying to find what is left. You know this because you did the long division and told me that every time you draw the line, you're finding the remainder. Matter of fact, I was pleasantly surprised, pleased that you recognize what you were doing. I never recognized what I was doing. All right, so very good. Then you see what is up here, so I'm carrying it back down here. So this 7x, I'm just going to carry it down here. So then, sir, why? Because I have 1 term, 2 terms here. In this line, I have 2 terms. Why? Because in that line, I have 2 terms. I have 2 terms as my divisor. It means that each time I must have 2 terms as my remainder. I have 2 terms as my divisor. It means that I must have 2 terms as my remainder. Any number of terms I have as my divisor is the same number of terms I should have as my remainder, because each term is going to be paired with the same number of terms. All right. So I'm just going to take this 7x and just put it down here. And guess what? I'm going to start the process again. Watch me. How many times can this x go into negative x squared? And the answer is negative x times. See the negative x up there? So that's a negative x times. All right. And then I'm going to say negative x times x gives me that negative x squared. Oh, sir, I see it now. You say what can go, how many times can the divisor go into the polynomial? And you write it up top as a quotient, and then you get to multiply the quotient by the divisor, and then you write it down to get the remainder? Absolutely. Let's go now. The same negative x is going to be multiplied by this 2 here that you're looking at to give me negative 2x. This negative 2x there. Also, we need to subtract now to find the remainder. Very good. So when I'm subtracting, hear me out. That negative x squared minus that x squared, you notice those 2 negative signs come together, negate and give you a positive sign. So it becomes 0. So that's how I don't have an x squared term down there. So that x squared term goes to 0. What am I left with? 7x minus 2x gives me a 9x. And that's why I get my 9x there. Let me stop and say something here. If you are so challenged algebraically, you are going to have a problem with this topic. Your algebra must turn up. Must turn up, because you see them minus 2, and then you have to go know that when you multiply 2 negative numbers, you get a positive number. If you don't know it, geez, peas, dog, yam, dog, eat your supper. You have to know it. All right, let's go. So x in, so I'm going to take this 12 and carry it down here. Remember, each time you're supposed to have two terms in there. Once it is the same number of terms you have as a divisor, should be the same number of terms every time you have down here. Look at that, two terms, two terms, two terms, two terms, two terms, until you can't write it as two terms again, and that's when you know it may stop. That's how you know when it stop. All right, so let's go. X into that 9x goes 9 times. And then I'm going to say that 9 times that x gives me 9x. And that 9 times this positive 2 gives me positive 18. Now I have my two terms again right there. So I'm going to subtract. Remember, you always subtract. You always subtract in order to find your remainder every single time, barring none. You always subtract. All right? Watch me. 9x minus 9x gives me 0. And 12 minus 18 gives me negative 6. So negative 6 is my remainder. So let us look, oh crap. So let us look at my therefore. Therefore, 2x cubed plus 3x squared plus 7x plus 12 is really my polynomial, which is the original question is given. That was given. Is going to be equals to my divisor, which is x plus 2, times my quotient, which is what is up top, 2x squared minus x plus 9, minus the remainder, or plus the remainder, but the remainder in this case is going to be negative 6. And that's what my division is, my long division is. And this, of course, is me using long division to find the remainder, because it says use synthetic division to find the remainder when the polynomial there is divided by that x plus 2. I know this was a mouthful. What I'm willing to do is to take your questions, I'll explain them, and then I'm going to give you a chance to look over this very example we just did, and then I'm going to project one for you. Oh no, I'm not able to project it with the same thing. Oh Lord Jesus, I have quite a number here to project, so you can start those for me, and maybe that will take us up into the end of the class because I don't need to go into anything else. I just want you to get your practice. As I said before, this topic is just really practicing, practice, 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 and once you practice, you get it. So we could maybe take a screenshot of this one here, but before we do that though, you could take a screenshot of my exercise 5.1, and then we're just going to sit and just work the questions in class. In a few questions, maybe about 3 or 4 questions. I know, as I did say to you, I'm a man of my words, and I get the general feel from the class that, on a tired, there's a final class. I can't finish at 7:30. I don't have a problem. But remember, say, all being welcome next term, you owe me 1 hour. So when I tell you, say, we now finish at 8:30, we'll go up to 9 o'clock. Nobody can say nothing because we are going to 1 hour. So I'm lending you this 1 hour now to take it back in next term. Do we have an agreement? Okay, I
Yes,
guess
sir.
Oh, because I was about to say we will go up until 8:30 then. Trust me, we have many more times with me because I know some of you, 1 or 2 of you are Adventists, but I must finish the syllabus and I will finish the syllabus with you at any cost. So if it means we tell yourself, guys, we're going to sleep and wake up and come back to the class, but we have to finish off. I'm super excited. I have not taught CXC, any of the CXC programs for many years. And I said to myself tonight, I cannot believe that I get caught in teaching CXC again. But I'm very encouraged. And I'm going to be very frank and honest with you. You guys on a Monday, Friday night, especially on a Friday night, not that I'm going to go nowhere now because COVID, but I really want to go bed and just go watch a little one movie and just get lazy. And I know you can do the same thing, but I don't know about you. But I really look forward to my class. You guys give me all the encouragement to come on, and I'm going to say something and I don't want the person to feel anyway. This is a family. When I see people like my Natty B, who say, boy, sir, me can't bother, I mean, Natty B, do the question and say, but sir, me not get the answer away from you. Those things encourage me. I'm very encouraged, and guess what? Nobody, no Minister of Education or Prime Minister of this country can question whether or not our online teaching in this class is being effective. Nobody can question that, because I know my students are learning. I have ways to find out if they're learning, right? So I'm just going to encourage you. The little break that you get, I remember when I was doing A-levels, the little break that you get is really not a break, you know. When I was studying, my break was Christmas Day, not even we call it day, Boxing Day. And then when Christmas Day done and the whole of the celebration and the man of food and I feel like he wants to leave, you take one little book and start with light reading, right? But I'm going to encourage you guys just to keep on doing what it is that you're doing. I am, but not lie, me feel very encouraged. Me feel very, 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 very encouraged. So keep up the good work. You have been doing very well, and I trust that you will continue in the new year to do well. So hear me out now. Are there any questions? Look at it, or you want me to? Let me give you some time first. Let me give you about 5 minutes to go through this on your own. Then you can jot down the questions that you have. And then I don't want to ask a question because I want to give everybody an opportunity to go through the question. Look at the question, and then I will take your answer, your questions, your comments there.
So
Say it again, please.
you couldn't like pick one next topic. Because what is
Exactly.
sir, the last day and then this I come with sir. I'm not telling them I'm bad. So what
No, like seriously, you think this hard?
sir, this I gonna take time for me. I can't talk for nobody else, but it gonna take time.
Jeez and peas. No, me feel hurt. You talk about you hurt, me feel hurt. No man, to be honest, it's really not bad. No, all right. Put fun and joke aside. No, and I'm gonna be very serious. I mean, yes, there is okay. We could have started trigonometry, but that would be worse. That would be very worse. You understand? But the truth of the matter though, if you were to ask me, and don't tell me that sir, you're a teacher, that's why. No man. Okay, if this helps in any way, shape, or form, I teach this topic to my pre-calculus students, and I will tell you the truth. You see, after the first class on this, the students understand it. I'm not lie to you. All I'm going to ask you to do for me, and I'm still going to finish within the 1 hour, give you the 1 hour time off, because I'm true to my words. And if I say something, I really want you to believe me, and I'm not going to go over the time because I want you to be able to trust me. If I say I'm going to give you the time, I'm going to give you the time. What I'm saying to you that we have 34 minutes to catch this, and we're catching the. You notice I said this is already, you see these questions right here. We want to do 1, 2, or 3, or 1 or 2, right? What I'm saying to you is that we're going to look at this division. We're catching this division. So we don't want nobody say, boy, I'm tired, I want to sleep. We're going to catch this. Finally, before I move on, a lot of you as science students would want to go into the Faculty of Pure and Applied Sciences. Some of you want to go to medicine, some of you want to go to engineering, maybe 1 or 2 of you want to go to law, etc., right? I wanted to go somewhere else, but I catch up in Faculty of Pure and Applied. Well, sorry, what you have now is science and technology. In my days, it was Pure and Applied Sciences. And I will tell you what them wicked people, no one can say it. I'm going to tell you what them wicked people they used to do. Today's Friday, over Pure and Applied Sciences, what the man them used to do is our exams, the Pure and Applied Sciences students, when we're doing our end of our December exams, we normally have all of our exams within the first week. So if you're doing chemistry, biophysics, math, geography, geology, them little biochemistry and them little hard something there, you have 1 paper today, and once if you have one lab exam, we blow. You have lab exam, and then you have to run from one exam to the next exam. And sometimes you Pure and Applied, science and tech, each up on one side of the university, And sometimes the exam there are all dramatic theater way over the next section of a university. By the time you run over there, so you're tired. And I'm telling you, you see what them teach we on a Friday like now, best believe set up on the exam paper. The Monday, you pray to God you don't have a morning exam. I know what I used to do? I used to say to myself, because when we get your first trend, I used to say to myself, you lucky. Because the last topic, if me not catch it in a class, I eat that. So we better learn. We better learn. We better learn the other topics that the man them teach. Because I'm telling you, it has happened to me many times over. They may cram like all 2 topics in one class, and at the first question you go into the exam paper and you say, okay, next, and just move on to the questions them where you know how to do, because you do them that long time, and you put all your marks right there, so, and then you go pat up on the one where you learn Friday. I mean, very frank and honest with you. I'm not saying that is a correct methodology, you know, but as science students, they expect us to know. So let us go. We are going to catch this long division before we go back tonight. Half an hour left. Let me go through it. Based on the question, let me go through it one more time. So the synthetic division, really and truly, it's not so bad. Up here says known as my quotient. Look at this. Look at the screen. That is known as my quotient. My quotient is what I get as a result of doing the division. That is known as my divisor. And this is known as my polynomial. And sometimes them call them dividend. Watch me. It's algebra. And we know a lot of students don't like algebra. So I'm not surprised at the comment. I don't think we are not hurt, you know. Really and should not hurt. Because I know, that's what I was saying to you at the start. If your algebraic skills not there, you're going to find it difficult. But let's go. I'm saying x into 2x cubed goes 2x squared time. Sir, how you know that? That was indices and logarithms. Right? So x into 2x cubed goes 2x squared time. And you write the 2x up there, so then we're going to reverse the process. What do you mean by reverse, sir? You're going to say that 2x squared multiplied by that x there give me 2x cubed. And then I'm going to go back to the 2x squared, multiply by the 2 to give me 4x squared. Oh, you did say, sir, that because you have 2 something over here, so you must have 2 something under here. So very good. Very good. And now that you have the 2 something them, sir, you have to go find the remainder. Excellent. And how do you find the remainder again? That's a question for you. How do you find the remainder again? By?
Subtracting.
By subtracting. So if you follow the same principle from little school, it's the same thing right here. So now, so I have to go subtract. What is subtraction? 2x cubed minus 2x cubed equal naught. That's why I don't see any x cubed under there. So, and then now I'm going to say 3x squares. That 3x squares minus 4x squares is going to give you a negative x squares. So it's the same thing we're doing like we did in little school, you know. The only difference is that we're working with variables now. That's the only difference. We're working with variables. See there? Look, let us look at another example, except this time it contains a variable. All right? And then remember, because we have 2 something over there, we must always have 2 something here. So that's why in that line, you're going to say negative x squared plus 7. So where that positive 7 come from? We'll go all it from up top here. So normally we'll see if I was doing it in a face-to-face class, you see me draw a line, come down here so until I reach a 7x. I'm pulling it down. I'm pulling it down. Then I know I have my 2 terms right there, so I'm going to go through the division again. It's the same thing I'm doing over 3 times. So why 3 times? Because the polynomial is raised to the 3rd power. Oh, I see it, sir. Yeah, man. So I'm going to say x into negative x squares goes negative x times. And that negative x times that x will give me a negative x squared down there. So,
Sir, I have a question.
Well,
The x, when x going at a 2x3, I thought it would be like 2x3, I thought the x would go into the 2x3 3 times. But you put 2. kind of confused right this so.
Remember, indices and logarithms, we say when we have when we're dividing and the bases are the same, what do we do with the powers again? Say subtract.
Subtract.
Right, so it's going to be 2x to the 3 minus 1. So where the 1 come from? Remember that x is to the first power there. So what we have is going to be 2x squares. See it now?
Yes, sir.
Yeah, man, very good question. Matter of fact, I was waiting for somebody to ask me that question, but because I did not give you a chance to talk just yet, that's why. It's a question that is asked every time I'm teaching this topic. So remember, when I say to you, how many times can x go into 2x squares? I mean 2x cubed. Anytime I ask that question, how many times can x go into 2x cubed? This is what I'm asking. 2x cubed divided by x. That's what I'm asking. 2x cubed. Technically, that's what I'm asking. 2x cubed divided by x. And I just said a while ago that we did indices and logarithms already. So we should know that when we're dividing and the bases are the same, I subtract my powers. I bet you nobody will ask that question again because you see, no, because the same principle we're using here is the same principle we're going to be using for all the questions that we're doing this long division. For all the questions we're using long division. All right? Very good question though. I'm happy that's the first question that came out of the box. All right, let's go again now. So we're going to say this negative x times this positive 2 now give me a negative 2x. I now have my two terms. So I'm going to subtract negative x squared minus the x squared is going to be 0 because minus x squares become positive x squares. So technically what I have is negative x squares plus x squares, which is 0. And then now I'm going to say 7x minus 2x, it becomes a positive 2x. So 7x plus 2x will give me 9x. And once I get that 12 is going to carry all the way down to right there. So, and then the final leg of it is how many times can that x go into 9x? And it goes 9 times. And then I said that 9 times that x will give me this 9x. And this 9 times this positive 2 gives me this positive 18. And again, I have my two terms right under there. So it means that I must now find the remainder. Remember, every single time when we're trying to find the remainder, it is at that time we are going to be subtracting. So 9x minus 9x is not. And 12 minus 18 is negative 6. And that's how I get my answer. Field your questions to me now. Any question? No more questions? Everything all right? How we feel?
I think I'm good.
Good. Okay-ish.
Okay-ish. And you know, guess what? That's a very good answer. It's a very good answer. Do me a favor. Do me a favor. Oh Lord, how should I do this? I don't want to stop share. I want to stop annotate. Oh, good. I was looking for the erase button. So now that I stop annotating, the thing that I wrote went. Do me a favor. Take those, just snap those questions for me, please. We're not doing all 9. I have 22 more minutes. I'm going to give you question number 1.
Sir.
Huh?
question, I can't go snap it in my go write down everything, so I'm gonna need more
No,
time.
but okay, that's fine, that's fine, that's fine. So just don't write on everything because I'm going to send you the questions. Write the first question for me, please. Let us spend some time on the first question alone. So we're just going to do one question. One more question and we'll call it a night. 3x cubed plus 2x squared minus 6x plus 5. And we're dividing that by x plus 1. Write that off for me, please, everybody. And when you write it off, let me know so I can project the workout that I have up top there. And then we'll just go through it together and we'll call it a night. Remember, me ready to finish class, So I have to go hurry up and do it. So we'll finish at our 7:30 time as we promised. All right. So let me know when it write off so I can project the working note for the first example I did. So we can move on. Make sure you write out the correct question here. That's one of the things that
Sir, look at it. That come over right. 3x squared.
Same thing. And I remember what TT said earlier. Sir, me good at creamers, if only me would just write only something them correctly and me good to go. Me know if it doing, sir, but me just write on the wrong signs them. Anyhow, TT, over the Christmas, me I'll carry go beach here so you can wash off the science problem you have. All right. Let's go. I can move from question 1.
Yes, sir.
All right. I'm projecting this. I'm going to give you about 10 minutes of undisturbed time just to work the question, and then I will come and ask you. So let me mute. How do I do this? Okay, hold on 1 minute, please.
Sir? Sir? Hello?
All right, somebody was trying to get my attention a while ago.
Sir, I'm gonna try the question. I just wanted to ask.
Okay, you're trying to get my attention a while ago. You're saying hello, right?
Yes, sir.
Okay.
I just wanted to ask if the
Go ahead.
answer that I have is correct.
Okay. What answer you got?
So on the top, I got 3x squared minus x plus 4x, and the remainder is 4.
Okay. Did anybody else get that?
No, sir.
What you got?
No, sir.
Sir, my remainder is 10. And at the top, I have 3x squared minus x minus 5.
Did anybody get the remainder 10?
Sir, not finished.
All right. Let us
Yes,
give them
sir,
another.
still working.
Okay, let us give them another 3 minutes and then I'll come back to you. So just hold on a minute, please. I'm right here. Just hold on a minute, please. Soon come.
Sir, finish. And I got 10 as the remainder as well. Sir,
All right. Yes. Go ahead. Mommy, please. Finish now.
Yes,
yes,
sir.
What's your remainder?
sir, I got 10.
10.
You got 10. Um.
Oh my god.
Yeah. You so it feels. This is what this is what hard work does. When you do something and you get the answer, you feel good within yourself. Very nice. Very nice. All right. Now, um, who got who got who got something other than this? You want to look at it? You want to talk to me about it? How you feeling? Matthew, did you get the answer?
Yes, sir.
Very nice, Papa. Very nice. Natty D is not to be here.
Yes, sir.
How you feel, mommy?
Sir, I'm not have a feeling.
What do you mean you don't have a feeling not to be? Not to be. What do you mean you don't have no feeling?
Sorry, this one will take a long time as well it's before. So I may just have to go work fine.
All right, and that's fine. And that's fine. All right. Do me a favor. Do me a favor. What should I do? All right. I have 5 minutes left. I have 5 minutes left. I have 5 minutes left. Do I have a second one? 2x cubed minus plus 5x squared. All right. I have 5 minutes left. I have the second answer there. I'm going to give you the 3 minutes to do it, and then we just discuss it now because I promise you the 7:30, and I'm going to stick to that. So try this one for me, please. Write it out for me so I can. Matter of fact, go ahead and start it. You have the working out for the first one already, or would you like me to project the first working out?
Sir, I have it already.
All right, go ahead and start working. Not to be, especially you, I want you to work on that one for me, boo.
Sir, I don't know what me I do.
What was that?
Sir, I don't know what I'm doing.
Okay. Where are you? Talk to me now. Where are you?
I'm gonna reach nowhere. Sir, I'm so tired.
Natty. Calm down, mommy. You were having challenges with some other topics, and you calmed down and you got them. It's the first to see this one, mommy. You will get it. Don't worry yourself. Me have the confidence, you want to get it too. Don't worry about it, man. All right, you know what I'm going to do? But in the interest of time, the rest of you continue working. C number 2 there, Natty. All of you look at that for me. I mean, the ones who are working, don't look at the screen. Natty, look at that for me.
Sir.
Yeah. What's up?
Sir. Where you get 9x from? And minus 4x squared.
All right, good question. Where you get 9x from? Which of the 9x? One up here, so?
Yes, sir.
All right. So let me just go through the question and then wrap it up. So x into 2x cubed goes 2x squared times. That 2x times that x out there will give me 2x cubed. And that 2x times negative 2 will give me negative 4x squares. But remember, when you're in little school and you're finding the remainder, in order to find the remainder, you have to subtract. You have $100 and you bought a patty for $57. What is the remainder? Meaning, how much is left? You have to subtract that 57 from the 100 in order to find out your remainder. So I'm subtracting. And that's why I have the subtraction sign on the outside there. I forget it on the first, in the first example. So you notice I have my subtraction signs on the outside. I forgot it for the first example. So I'll put it in. So I'm going to say now 2x cubed minus 2x cubed gives me naught. There's no 2x cubed right there because I would have eliminated it. All right. And then I'm going to say 5x squared minus a minus 4x squared gives me a 9x squared. So how do you get that? Because when I multiply this negative number by this negative number, I get a positive number. And that positive number plus this positive number gives me a bigger positive number. Follow me?
Yes.
Say yes. Good. And this negative 7 up here, I'm carrying it all the way down right here. So I now have my two terms right there. Watch me now. X into 9x squares goes 9x times. So that's why I get that 9x. That's why I get that 9x. And then I'm going to say 9x times this x to give me 9x squares. And the same 9x times negative 2 gives me a negative 18x. So just follow the sequence. You put something into something and it go up top. And then we use the top one to multiply by the divisor. And then we're subtracting. So it's 9x squares minus 9x squares is naught. And negative 7x minus a minus 18x becomes negative 7x plus 18x, which is 11x. And then I'm carrying this 12, look, all the way down right there. So, and I'm saying now, x into 11x goes 11 times. And then that 11 times this x will give me 11x, and 11 times -2 gives me -22. And the same thing we've done right here, so, and right here, so, but we're going to do it right here, so. So it's the same thing you're doing over and over and over and over, just like Cramer's. How do we solve a 3x3 system of equations? We find the determinant. The determinant for the overall the matrix, the determinant for x, the determinant for y, the determinant for z. All you're doing is just changing the matrix each time so that you get a different matrix so you can calculate the determinant. All we're doing here is the same procedure here, here, and here. So 11x minus 11x is not. Watch this. 12 minus 22 becomes 34. Why? Because this becomes 12 plus 22 to give me 34. Who got 34 for their answer?
Me, sir.
Me, sir.
Very, 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 very good. All right. So those of you who said me, talk to me. Was this very, very, very difficult?
No, sir.
No, sir.
No, sir.
All right. Natty, don't feel bad. Natty, say you beat up yourself too much. And that me not like about you, you beat up yourself too much, man. Just take it easy, man. All right, I'm going to end here, but I'm going to send you some stuff that I really want you to go through. And I won't message you Christmas Day, but I mean, we can have conversations every now and again in the WhatsApp just to make sure that people are on top of things. And then we'll continue, when school reopens. But a good work. Thanks again for coming out.
Yes, sir. No problem.
Get some rest.
Thank
All
you,
right,
sir.
Bye,
Yes,
sir.
Bye-bye.
Bye-bye.